Hey, feeling good, like I should. When in dark, walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework for lesson 8.3.2. We're going to start off with M&M's for angle relationships. It says it is common to identify angles using 3 letters. For example, angle ABC means the angle you would find by going from point A to point B to point C in the diagram here. All right, so I don't like that explanation. This is the explanation I like. Angle ABC is the angle where the letter that's in the middle, the B, is your vertex. There's your vertex right there. So we've got 3 different angles coming out of this. You got angle ABC, where you've got the rays that come from point B. So one of them goes through point A, the other one goes through point C. So this is angle ABC. If we're going to talk about angle CBD, angle CBD is going to have a vertex of B as well. But this one is going to have rays that pass through point C and point D. Those are the 2 points on the other side. So this would be angle CBD. And then, of course, you've got angle ABD, which once again, let me go ahead and clean this up a bit. Angle ABD is going to have the vertex that's in the middle. That's the B, is always the vertex in the middle there. And then you've got rays that go from B through A and a ray that goes from B through D. Okay, so the reason why we use 3 letters to name these angles, and that would be the right angle, right? The entire one, or actually we should do it like that. The reason why we do that is because you can't just call this angle B. Like if I did this and said, well, that's angle B, hooray. Well, there's only one angle there. So we could just call it by a single name. But if I call this angle B, I don't know which one we're talking about. Is this the angle B you're talking about? Is that the angle B you're talking about? Or is this one the angle B you're talking about? So there's that method for naming angles. Okay, so if you need to back that video up and listen to how I described it again, go ahead and do it again. Just notice that the vertex for all of the angles has to be the center letter in the names of the angles. So here you notice the vertex is F for this angle, and for that angle, notice how the F is in the middle. All right, so now let's take a look. I'll get rid of all that. Let's take a look at the difference between supplementary angles and complementary angles. The complementary angles always add up to 90 degrees, such as these two, right? A 50-degree angle and a 40-degree angle combined would form a 90-degree angle, similar to what we've got right there, right? This angle plus that angle makes the 90-degree angle. They are complementary to each other. This one and this one are complementary to each other. Then you've got supplementary angles. The supplementary angles are the ones that add up to a total of 180 degrees. So when you put them next to each other, they're going to form that straight line. Okay, so the straight angle, nope, 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 nope. The straight angle is 180 degrees. It consists of this angle and that angle right there. Then when you've got 2 lines that intersect each other, you've got adjacent angles. Those are the angles that are right next door to each other, right? Those 2 are adjacent to each other. These 2 are adjacent to each other. These 2 are adjacent to each other, and these 2 are adjacent to each other. And it just so happens that when you've got 2 lines intersecting each other, the 2 angles, or any 2 angles that are adjacent to each other, are also going to be supplementary angles, right? Because they form that straight line. And you've got your vertical angles. The vertical angles are the ones that are across from each other. So angle C and angle D are vertical angles, as well as D and F would be vertical angles. And the thing about the vertical angles is they are not supplementary. They are actually equal in measure to each other. They have the exact same measure if you were to put up protractors. So let's take a look at this. Alexander and Santiago put 5 pattern blocks together with 1 vertex of each block touching, and that's the vertex right there. Or the vertices are all right there. as shown in the diagram. Work with your team to find the measure of the smaller angle of a beige rhombus. So this is considered right here a beige rhombus. I don't know if you've ever seen those, what do you call those? Yeah, they're the pattern blocks. I guess, are all pattern blocks beige when they're rhombuses? I don't know. But at any rate, you can see that you got 1, 2, 3, 4 of those, which are all the same measure, and then this 60-degree angle in this green triangle here, all of them put together form this straight line, this straight angle, which makes them all combined are supplementary. So you are going to add the 4x's plus the 60 to get 180, which means that the 4x's by themselves have to be 180 minus the 60. They have to be 120. So if you multiply 4 times x to give you 120, then you can figure out what x is equal to by dividing each side by 4, and 120 divided by 4 is 30. So each one of these are 30-degree angles. Now we can prove it by saying, well, if this is 30, and this is 30, and this is 30, and this is 30, then let's just add them all together. You got 90, 120, 150, 180. Yes, they all add up to 180 degrees. So that is the answer. Use the vocabulary terms you learned today to classify the following angle pairs. You got complementary, supplementary, adjacent, and vertical. So these two angles are vertical angles. They are across from each other, and they are equal in measure. These two add up to 90 degrees, so they are complementary angles. These two add up to 180 degrees, so they are supplementary. And these two are adjacent to each other because they share a vertex. They have a common ray for a side, and they're right next to each other. They're right next door. So it doesn't matter what they add up to be adjacent. They can add up to anything. All right, graph the following points on a coordinate graph. -3, 3, or -3, -3 is point A. So we've got this down here. -3, -3 right there. You've got point 3, 0, which is point B. You got 3, 6, which is point C. And you got -3, +6, which is point D. Describe the shape that we've created. Okay, well, that's a trapezoid. Trapezoids are quadrilaterals. That means they have 4 sides, and 2 of the sides are parallel to each other. So since these are the sides that are parallel to each other, those would be considered the bases of the trapezoid. But this problem isn't about finding the area. This problem is about something else. Identify the types of angles at these points. Right? So, well, that's a right angle. That's a right angle. This is acute, and this is obtuse. So there you go. Classifying the different types of angles in this trapezoid. All right, another box plot problem. It says scientists studying prehistoric birds have estimated the weights in grams of 2 different subspecies of birds. I don't know what pre and post emergent means. This problem really frustrates me every single year because I don't get it. Thrushes is a type of bird. I've always thought pre-emergent thrushes were birds that were still in the egg, and post-emergent are ones that hatch from their eggs. But it wouldn't make sense that they're 2 different subspecies. I don't get it, but whatever. We just call these, I don't know, whatever. Call them whatever you want. This just makes me mad. I'm sorry. I'm going to stop ranting. All right, so what do we need to do? We need to take this data and put it into a parallel box plot. And a parallel box plot is going to be one where you find all the necessary information, the minimum, the maximum, the quartiles, and the median for each of these particular types of birds. And then we reference both of the box plots on the same exact number line. So here we put the numbers in order from least to greatest. We've got the minimum and the maximum are shown here and here. Your median, what do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we're going to have one number in the middle because there's an odd number. So half of 15 is 7.5. So 1, 2, 3, 4, 5, 6, 7. This would be the number in the middle. 68 is your median. And then you take your lower quartile. What do we have here? 1, 2, 3, 4, 5, 6, 7 numbers below. So 58 is in the middle there. That's your first quartile. And 1, 2, 3, this number's in the middle. So that's your upper quartile. So we take all of those numbers and we reference them against a number line Here's your minimum, 49. Here's your maximum, 83. Here's your median, 68. Here's your first quartile, 58. And here's your third quartile, 73. Notice how all those numbers are all accurate for their positions on the number line. I don't want to mark that up though. All right, now we get to post-emergent thrushes, where we've got your minimum and your maximum are 29 and 27. That's interesting. The pre-emergent thrushes have a much smaller range of weights compared to the post-emergent thrushes. They are both lighter and heavier for the post-emergent. All right, so how many numbers are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This means we got two numbers in the middle. So 1, 2, 3, 4, 5, 6, 7, 8. You got to find the halfway point between those two numbers. That's going to be your median. And then everything below the median, 1, 2, 3, 4, 5, 6, 7, 8, means you got two numbers here. So that's going to be 57.5. And 1, 2, 3, 4, you got two numbers there. Our median's going to be the halfway point there, which is 87.5. Now we take our post-emergent thrushes and we label our minimum, our maximum, our median is 87, no, what is it? 73.5. Our first quartile is at 57.5 and our, 57.5, and our third quartile was at 87.5. Okay, so much more spread out post-emergent thrushes. You look at the interquartile range here, it has almost the same range as the entire data here. Look at how that's almost the size of this. Okay, so much more spread. So what's the question that's being asked? It says, would the mean accurately represent the middle of the data? Why or why not? Okay, so what's the difference between mean and median? The mean is where you add up all the numbers and then divide by the number of numbers, and that generally gives you a very accurate average, except when you've got an outlier. When you've got an outlier in your data, the mean is going to get skewed. Okay, so if there was one post-emergent thrush that weighed 1,000, what are these, grams? 1,000, and you would have this be, that would be a huge outlier, and that would change your mean significantly. So, but it would only change the median. In fact, if we replace the 97 with 1,000, the median would still be at 73.5. If you added 1,000 here, now the median would become the 74, which is not much of a change. So when you've got an outlier, you choose the median as your average, and that's going to give you a much more accurate average. So the mean is going to be pretty accurate because there doesn't appear to be a clear outlier either on the minimum side or on the maximum side of either one of these. And then it says a fossil of a bird is found. Scientists estimate that the weight is somewhere around 75 grams, or was when it was alive. So which is it more likely to fit into? 75 grams would be right here or would be right there. Okay, so if it's a pre-emergent thrush, then it is in the 25% range of all thrushes falling in this category. But if it is a post-emergent thrush, then it falls right in the middle of the data, right in the average, very, very close to the median. So based on the fact that the median is kind of like considered that one number that best represents this particular species of bird, it's so close to that median, I'm going to go ahead and suggest it's much more likely that it's going to be a post-emergent thrush than a pre-emergent. Could it be one? Sure. It would fit right in here if it was a pre-emergent thrush, but it would fit right here if it was post-emergent, and that's closer to the center, so it's a higher likelihood it's going to be the post-emergent. But we don't know for sure because it was probably millions of years old, so whatever. Let's move on. All right, a candy store specialty is taffy. Customers can fill a bag with taffy, and the price is based on how much the candy weighs. Store charges $2 for 10 ounces. So that is a piece of information that we would need to figure out what the unit rate is. That's this piece of information right there. So is this a proportional type relationship? And the answer is absolutely it's proportional, because you can figure out what the unit rate is. And in this case, the unit rate looks like it's going to be, probably 20 cents per ounce, right? If it's 2 ounces is 40 cents, and 5 ounces is $1, and 10 ounces is $2, and the unit rate, which we could use here, is going to be 20 cents per ounce. So 5 times that is 1, 10 times that is 2, and so on and so forth. So the fact is, if you were to buy 0 ounces times 20 cents, you're going to pay $0 or 0 cents for that particular tap fee, right? So 0, 0 applies. When you look at the graph, you see it passes through 0, 0, and it's a straight line, which implies there's a constant growth rate. In this case, the unit rate is the 20 cents per ounce. All right, 5D process. Ella is trying to determine the side lengths of a triangle. She knows that the longest side is 3 times longer than the shortest. So I'm going to make this the shortest, and that's the longest. And then the medium is 10 more than twice the shortest side. So if we're defining the shortest side as x, then this will be 10 more than 2 times x. The perimeter you get by adding all 3 sides. So there's the short side, there's the medium side, there's the long side. Add them all together by combining like terms. You get 6x plus 10 is equal to the total perimeter, which is 142. So it means that the 6x's must have been 132, since 132 plus 10 is 142. And then when you divide 132 by 6, you will get 22. So that means that the shorter side must have been 22. If that's the case, then the longest side must be 66, and this must be 10 more than 44, so this would be 54. If we add all those together, what do we get? 22 plus 66 plus 54, that's 12, carry the 1, that's 11, 12, 13, 14. That is indeed 142. So we can declare our answer, which is, how long is each side? We will declare the length of each side. And that is it for our homework. Hooray. Let's move on to the next activity. Bye.
Hey, feeling good.